Finding the number of terms in a finite arithmetic sequence. Explicit formulas can be used to determine the number of terms in a finite arithmetic sequence. We need to find the common difference and then determine how many times the common difference must be added to the first term to obtain the final term of the sequence. Given the first three terms and the last term of a finite arithmetic sequence, we want to find the total number of terms. Step number 1, we're going to find the common difference first, d. Number 2, we're going to substitute the common difference in the first term into the formula. And then step 3, we're going to substitute the last term for a subscript n and then solve for n. So for example 6, we're finding the number of terms in a finite arithmetic sequence. Find the number of terms in a finite arithmetic sequence. So in this case here we have 8, 1, -6, ... to -41. So this is a finite sequence because it ends at -41. We want to find out how many terms total are in this sequence. So the first thing we need to do is find the common difference by subtracting the first term from the second term. So 1 minus 8 is equal to -7. So we know that the common difference is -7, excuse me. So we know that d is -7. And we know that the first term is 8. And we also know that the last term, or the nth term, a subscript n, is -41. So using the formula, we have the nth term here, we have our first term here, and then we have our common difference here. And so what we want to look for is this n. This is what we need to look for. So by doing that, we can say, okay, well, we got a subscript n. We know that the first term is 8. We know the common difference is -7. And then we're going to distribute this -7 to both of those terms. So we get 8, -7 times n is -7n. -7 times -1 is +7. And so 8 plus 7 is 15 minus 7n. Now, going back to what we stated before, a subscript n is the nth term, and the nth term was -41. So in order to solve for n, we're now going to replace this a subscript n with -41, and then we have our formula 15 minus 7n. And so the next step is to solve for n by first subtracting 15 to both sides, and that's going to give us -56, and then we're going to divide by -7, so -56 divided by -7 gives us +8, so n is equal to 8. So what does that tell us? That tells us that there are 8 terms in the sequence. So n is telling us how many terms that are actually in this sequence.